Have you ever wondered how food production looks like around the world? A pig farm in the Netherlands, for example, looks quite different from a smallholder farm in Zimbabwe. To improve the environmental performance of food production systems, you must understand their diversity, as each system has its own environmental issues. Food systems differ because of differences in their agroecological context, socio-economic context, and differences in farm management. The agroecological context of a system, for example, is determined by the soil type and the local climate, whereas the socio-economic context is determined by the market and the political situation. A food production system can consist solely of plants or animals or both. It can produce just enough food for the family or produce for the commercial market. It can depend solely on rainwater or use irrigation water. Finally, a farmer can settle in one place or move around looking for new pastures or plots to cultivate. A crop farmer can grow annual crops or perennial crops. Choose to grow only one crop or several crops simultaneously. Plants can grow in the open field or in a greenhouse. A livestock farmer can keep solely monogastric animals or ruminants or both. He or she can grow livestock feed on the farm or import the majority of the feed. Animals can have access to an outdoor run or to grazing fields or can be kept indoors all year round. I will now show you a few typical systems and introduce you into their specific environmental challenges. Here you see, for example, a grass-based system in New Zealand. Pasture grass is the main feed source for cows in New Zealand. In spring, pastures grow most rapidly and cows produce most milk. The majority of the cows, therefore, calve in July and August so that their peak production occurs at the same time as the maximum grass production. Grass and reproductive performance, therefore, are essential. The expansion of the dairy sector, however, has contributed to eutrophication of water bodies. And this sector also contributes significantly to the natural emission of greenhouse gases. The main challenge of this milk production system in New Zealand, therefore, is to improve grazing and herd performance in order to reduce eutrophication and emission of greenhouse gases. Here you see a pastoralist system in Tanzania. Pastoralists herd livestock in order to find fresh pastures on which to graze. This way of life fits the dry areas in the tropics. Pastoralism is central to the livelihoods of a large part of the population in Africa. Livestock in these systems not only produce food and hides, but they also serve as capital asset or have a social status function. Pastoralists conserve rangeland biodiversity and protect ecosystem services. In some areas, however, where pastoralists are prevented to migrate, overgrazing occurs, resulting in biodiversity loss and soil degradation. Here you see a specialized corn farm in the USA. Corn is produced as food for people, feed for animals, and fuel for cars. To increase this productivity, farmers use fertilizers. These fertilizers, however, can easily run off and cause eutrophication. In high plains, such as in Kansas, farmers also irrigate their corn, resulting in depletion of groundwater. Environmental issues related to US corn production, therefore, are nutrient losses to the water and depletion of water bodies. Here you see an example of a small-scale mixed farm in Zimbabwe. This smallholder system cultivates crops and keep livestock, mainly for home consumption. Maize is the main staple crop, but farmers also grow groundnuts, sweet potatoes and vegetables. Crop residues are fed to the livestock, and during the day, cattle graze in the woodlands. At night, cattle are kept at the kraal. Farmers, however, do not use manure from the kraal to fertilize their land, and they also cannot afford to buy synthetic fertilizer. The main environmental issue of this system, therefore, is soil degradation, due to repeated cultivation without soil amendments of manure and fertilizer. Here you see an example of a so-called landless system, namely pig production in the Netherlands. A landless system typically has a high animal density and relies on the import of feed. In fact, this system is not landless, as we do need land to cultivate all the imported feed. Especially if proper manure management is lacking, this system can result in local eutrophication. Furthermore, production of feed, such as soybean meal, can result in environmental concerns in other parts of the world, such as deforestation. Besides these environmental challenges, this landless system often faces social challenges, like concerns about odor nuisance and animal welfare. Here you see an example of a fully automated, climate-controlled farm in Japan, producing lettuce. This farm combines biological knowledge about plant growth with technology. By controlling the light, temperature, humidity, and irrigation rate, a farmer can produce in a rather resource-efficient way. The major challenge of this system is its energy use. In case we combine indoor plant production with energy-saving technology, such as the use of LED light, and the use of renewable energy, this system has great potential to be environmentally sustainable. In this video, I showed you the diversity of food production systems. This diversity implies that there is no unique, simple solution to improve the environmental sustainability of all systems across the world. To improve the environmental performance of a system, you first need to understand the system and its context.